Hi everybody. So in this video I'm going to show you how we can interpret a histogram. And in the previous video, where I covered how to plot a histogram, we discussed that the frequency is a measure of the area of a bar rather than its height. We use the area for frequency because the class widths are different. For instance, this bar's got a width of 20, but this one has a width of 10. So this is why we use an area for frequency rather than the height. So in this example, we're told that a biologist measures the length of fish found in a coral reef and represents the data in a histogram. For part A, how many fish were included within the sample. So we need to work out the total frequency from this histogram, which means we need to find the area of each of these bars. So if we begin with this bar, we know this is just a rectangle. So to find its area, we multiply the length by the width. We know the length is 20 centimeters, the difference between 10 and 30, and we know the height at a frequency density of 2. So this bar will have a frequency of 40. For this bar, the width will be 20, 50 take away 30, multiplied by the height, which is a frequency density of 5. And 20 times 5 gives us 100. In our next one, we've got a base of 10 and a height of 8. So 10 times 8 will give us a frequency of 80. And then and for our final bar, we've got a base of 10 and a height of 2. So we'll get an area or a frequency of 20. So to work out how many fish were included, we just need to add up these frequencies. And this will give us a sum of 360 fish. Okay? And then for part B, to find the number of fish with the lengths between 40 and 60 centimeters, well, I'll shade this on the histogram. So between the lengths of 40 to 60, we're looking at this shaded area. And you can see between 40 to 50, we've got half of the 100. So this will be 50, plus the bar between 50 and 60, which is 80 fish. So this will give us a total of 130. And then for part 2, the number of fish with lengths between 20 and 50 will be in this region that I've shaded in blue. So we're looking at all of the 100 and half of this 40. So this will be a total of 120 fish. And then we're asked that a fish is chosen at random and to estimate the probability that it has a length less than 35 centimeters. So we've just worked out that there's 360 fish in total. So the probability of a length being less than 35 will be out of 360 fish. So now we just need to work out the number of fish less than 35. We know 35 is a quarter of a way between 30 to 50, and this will be a quarter of 100. So we'll have a 25 here, plus this 40. So we'll have a total of 65 fish. And we can simplify this fraction, and we get 13 out of 72. Okay? So this is how we can use the area of a bar to interpret a histogram. In the next question, we're going to look at how we can estimate the mean from a histogram. So in this question, we're told that the histogram shows information about the masses of 54 oranges. We've been asked to calculate an estimate for the mean. So perhaps you want to try this question yourself. You can download a copy of a PDF from my website. I'll leave a link in the description below. And then you can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back. So the problem we have in this question is that we haven't been given the scale for the frequency density. But what we have been told is that the total frequency is 54 oranges. So what we can do is work out the frequency that's represented by each of these smaller rectangles. If we count the number of rectangles, we've got 14 here, another 8 here, 2 here, and 3 on top. So if we add all of these together, we've got a total of 27 smaller rectangles. So we can do 54 total frequency, divided by that 27 tells us that we've got 2 oranges per smaller rectangle. And then we can use this idea to work out our frequency table for us to calculate the mean. So between 0 to 20, we've got a frequency of 8. Between 20 to 30, there's 5 rectangles, so we've got 5 times 2, which gives us a frequency of 10. Between 30 to 40, we've got a height of 8, so 8 times 2 will give us a frequency of 16. And then 40 to 60, we've got 2 by 4, so again, frequency of 16. And then finally, we've got a frequency of 4 here. Now to work out the mean, we need to work out the midpoint, and this is the middle of each bar. And halfway between 0 to 20 is 10. Between 20 and 30, 25. Then we'll have 35, 50, and 65. Now to work out our totals, we'll multiply the frequency by the midpoint for each of these rows. So we'll have 80, 250, 560, 800, and 260. And we know the mean is the total divided by the sample size. We can work out the total by adding all of these together, and we get 1,950, and we're told that the sample size is 54 oranges here. This gives us an average of 36.1 grams per orange. Okay, well, I hope that's given you an idea on how we can interpret histograms. If you did find that helpful, please like and subscribe, and you can download the video PDF and the full lesson from my website, mrmathematics.com. I'll leave a link in the description below.